Poisons have captivated the human imagination for centuries. They are silent weapons capable of inflicting death with chilling stealth. From the poisoned apple in Snow White to the deadly concoctions of history's most infamous poisoners, these substances hold a unique power over our fears and fascinations. We often associate poisons with their immediate lethal effects, envisioning them as ticking time bombs of toxicity. But what happens when a poison expires? Does its potency wane with time, rendering it harmless? Or does it transform into something even more sinister, its danger amplified by the passage of time? The answers to these questions are far from simple, as the aging process of poisons is a complex and often unpredictable phenomenon. This exploration delves into the intriguing world of expired poisons, examining the scientific principles that govern their decay and the potential consequences of encountering these aged toxins. Join me as we unravel the mysteries surrounding these substances and gain a deeper understanding of their enduring power. We will also uncover fascinating historical anecdotes and scientific studies that shed light on the evolving nature of poisons over time. Prepare to be both informed and intrigued as we venture into the shadowy realm of expired poisons. The question of whether a poison becomes more or less toxic after its expiration date is not easily answered. It depends on a multitude of factors, including the specific poison in question, the conditions of its storage, and the chemical processes that occur as it degrades. Some poisons lose their potency over time, their molecular structures breaking down and rendering them inert. Others may undergo chemical transformations, converting into new compounds with different levels of toxicity. In some cases, these transformed compounds may be less toxic than the original poison, while in other instances, they may become even more dangerous. To understand this complexity, it's helpful to consider a few specific examples. Cyanide, for instance, is a fast-acting poison that disrupts the body's ability to use oxygen. Over time, cyanide can react with other chemicals in the environment, transforming into less toxic compounds. This degradation process is accelerated by exposure to light and air. Arsenic, on the other hand, is a notoriously persistent poison that can remain in the environment for centuries. It does not readily break down and can accumulate in the body over time, leading to chronic poisoning. The toxicity of arsenic is not significantly affected by its age, making it a dangerous substance even after long periods. To comprehend the effects of aging on poisons, we must delve into the realm of chemistry. Poisons exert their toxic effects through various mechanisms, often by interacting with specific molecules or processes within the body. As poisons age, their chemical structures can undergo alterations, potentially influencing their ability to interact with these targets. Oxidation is a common culprit in the degradation of many substances, including poisons. Exposure to oxygen in the air can cause molecules to break down, forming new compounds with different properties. Hydrolysis is another process that can affect the stability of poisons, particularly those stored in liquid form. Water molecules can react with the poison, causing it to decompose or transform. Additionally, exposure to light, heat, and changes in pH can all contribute to the degradation of poisons over time. These chemical transformations can have a significant impact on the toxicity of a poison. In some cases, the degradation products may be less toxic than the original compound, rendering the poison less potent. However, in other instances, the breakdown products may be more toxic, leading to an increase in toxicity over time. Cyanide, a highly poisonous substance, provides a compelling example of how expiration can affect toxicity. Known for its rapid and lethal effects, cyanide disrupts cellular respiration, depriving the body of oxygen. However, cyanide's potency is not everlasting. Over time, particularly when exposed to air and moisture, cyanide undergoes chemical reactions that diminish its toxicity. One such reaction involves the conversion of cyanide to cyanate, a less harmful compound. This transformation highlights the crucial role of storage conditions in preserving the potency of poisons. Storing cyanide in airtight containers away from light and moisture can slow down its degradation process. However, Even under optimal conditions, cyanide's shelf life is limited, and its toxicity gradually decreases over time. This case study emphasizes that expiration dates for poisons are not arbitrary, but rather reflect the chemical realities of these substances. In contrast to cyanide's relatively short lifespan, arsenic stands as a stark reminder of the enduring nature of some poisons. Arsenic, a metalloid element, has a long and notorious history as a poison. Unlike cyanide, which degrades relatively quickly, arsenic is remarkably persistent in the environment. It does not break down easily and can persist in soil, water, and even human remains for centuries. This persistence makes arsenic a significant environmental concern, as it can accumulate in the food chain and pose long-term health risks. The toxicity of arsenic is not significantly affected by its age, meaning that even ancient deposits of arsenic can still pose a danger. The element's ability to bind to proteins and disrupt cellular processes remains potent over time, making arsenic a timeless threat. Whether freshly mined or centuries old, arsenic serves as a chilling reminder of the enduring power of certain poisons. The expiration of pharmaceuticals, including those with potentially toxic effects, raises unique considerations. Unlike many naturally occurring poisons, pharmaceuticals are carefully formulated compounds designed to elicit specific biological responses. Over time, the active ingredients in these medications can degrade, potentially reducing their effectiveness or in some cases leading to the formation of harmful byproducts. The expiration dates on pharmaceuticals serve as crucial indicators of their stability and potency. Beyond the active ingredients, the excipients or inactive substances in medications can also degrade over time. These excipients, which help with factors like drug delivery and absorption, can become less effective or even contribute to the formation of harmful substances as they break down. Therefore, it is essential to adhere to the expiration dates of pharmaceuticals and to dispose of them properly to avoid potential risks. The exploration of expired poisons underscores the critical importance of proper handling and disposal of these substances. Whether dealing with household chemicals, medications, or industrial toxins, understanding the potential hazards and taking appropriate precautions is paramount. Storing poisons in their original containers, clearly labeled and out of reach of children and pets, is essential to prevent accidental ingestion or exposure. It is crucial to never mix different chemicals, as this can lead to unpredictable and potentially dangerous reactions. When it comes to disposal, following local regulations and guidelines is crucial. Many communities have designated collection sites or programs for hazardous waste, including expired or unwanted poisons. Proper disposal not only protects human health, but also safeguards the environment from the potential long-term consequences of these substances. The world of expired poisons is a complex and often unpredictable one. While some poisons lose their potency over time, others retain their toxicity for centuries, serving as silent threats long after their intended use. The chemical processes that govern the degradation of poisons are intricate and influenced by a myriad of factors, making it difficult to predict the exact effects of aging on every substance. However, one thing remains clear. The expiration dates of poisons are not arbitrary warnings, but rather reflections of the chemical realities of these substances. Respecting these dates and adhering to proper handling and disposal practices are essential steps in mitigating the risks associated with poisons. By understanding the science behind poison expiration, we can foster a greater appreciation for the enduring power of these substances and make informed decisions to protect ourselves and our environment.